Hey everyone, welcome back for the very last time this unit for Unit 10's Acid, Bases, and Salts lesson number 5, Titration. So in the last video, we covered neutralization reactions, how to write and balance them, and today is the last topic, which is titration. So a few things to kind of point out before we super get started. When we're talking about our acids bases, especially today, we want to look at how many H's or OH minuses our thing or our compound releases. So H will produce that when it's dissociated water, we'll have that release that one H. So we call it monoprotic. Mono meaning one, protic meaning proton. Remember, H plus is the same thing as a proton. H2SO4 produces two H's, so we call it diprotic. H3PO4 releases 3 hydrogens, so we call it triprotic. So again, we're looking at the H's in an acid. A base, if it releases one hydroxide group, we call it monohydroxyl base. If it releases 2, if it releases 3, you have those similar names. So looking at the formula itself definitely is necessary for these questions. And so if we're looking at this, if we have 1 molar of HCl, you have essentially think of it like this. You have one HCl molecule. Again, not totally accurate, but the way to think about this, you have one HCl. So you get 1 mole of H plus that gets released. If you have 2 HCls, so you have 2 of them, you have 2 things of H plus that get released. Because you have 2 things that each release 1. If you have one H2SO4, well, H2SO4 releases 2, and if you have 1 of them, you still release those 2 H pluses. But if you have 2 H2SO4s, H2SO4 itself releases 2 H's, but if you have 2 of them, you get 4. So that comes in handy when we're talking about our concentrations later. If you like thinking about it like this, fantastic. I like to add a little bit to our equation to kind of avoid any confusion or to make sure we don't forget about doing this. But with OHs, it's the same thing. So if you have 1 NaOH, it gives off 1 mole of OH. If we have 2 OHs, that's 2 of them, CaOH2 releases 2 OHs, but if we have 2 of them, that gives us 4. Again, if this way of looking at it makes sense to you, great. If not, don't worry, I have something in mind to help explain this later on. Now, titration, the formula itself is the concentration of A, molarity of A, times the volume of A, and A is your acid, equals the molarity or concentration of your base times the volume of your base. So this comes directly from table T. And so basically what's done is that you have a known concentration of one thing, a known volume of, you have a known volume and concentration of one thing, and a known volume of the other, and you're able to calculate the unknown concentration. And so we know it's done when it hits, and we call it an equivalence point when that neutralization happens. And so we know that based on a color change that exists with indicators. And so basically a neutralization reaction is going on, and we're able to tell when we've added enough either acid or base because we know when it hits that neutral based on the color of an indicator. So generally base is being added, but it could be done either way. And so what's going on, you have a flask, you know how much is in here, and you know the concentration of that, and you have an indicator, and most of the time we're using phenolphthalein. So everything in here is known. And here we have, one of the things is known, and then you have another solution, either an acid or a base, whatever the opposite is, and you'll open it up and put a little bit in at a time. Once the color hits a specific color, so when we're talking about phenolphthalein, it wants to be a very, very, very light pink. And so we know it hit that equilibrium equivalence point. You can measure the amount of volume you've used, and you can calculate the missing concentration. And so if we're looking at a graph of this, you have your acidic solution. Again, generally bases are being added. And then it jumps up, the pH jumps up. That right there is your equivalent point, and that is that very, very, very light shade of pink. If you've ever done titration, you probably will if you take chem in college. It's very, very easy to overshoot it and make it too pink. So very stressful for somebody doing this in the lab. But anyway, you guys are really responsible for the calculations of it. And so again, here is our table T equation. Let's go ahead and jump into this. Again, M is the molarity concentration of your acid, V is volume, A stands for acid, B stands for base. We got this. Okay, so MAVA equals MBVB. Okay, what is the concentration of a sample of HCl, 30 ml sample of HCl, if it can be neutralized by 50 mils of a 1.2 molar solution of NaOH? So again, whenever we do any equation, I like to list everything out, MAVA. And I also like to just list out the number of H's, just so I don't forget to incorporate that later on. Same thing with my bases, B, volume of my base, and then my OHs. So, in looking at this, 30 ml sample of HCl, that is our acid, though 30 mils is our volume. In our formula HCl, there is one H, so I put that there. What is the concentration? We're looking for that. And then in our base, 30 mils of that. So we have, 50 mils of that. So you have 50 mils. 1.2 is our concentration. And then in NaOH, we have one OH group. So now that we have everything we need, we can plug in. So we get Ma times 30 times 1 is 1.2 times 50 times 1. And so do some multiplication. Ma times 30 times 1 is Ma times 30. 1.2 times 50 times 1 is 75. We want to get Ma by itself. Divide both sides by 30. The molarity, or the concentration of our acid, the number is 2.5. And our unit, remember, you can even just look at the other thing, is M. Molarity is capital M. So you have a 2.5 molar solution. That's it. Let's just do one more example, slightly different. So again, one list of MA, VA, H, and you'll see why I'm doing the last step more in this example, VB, OH. So we have this. Again, this is going to be our acid, 3.0 molar. Our volume we do not know, we're looking for. And now, in this formula, we have two H's, so that's where 2 comes in. With our base, we have 50 mils of it. Concentration is 1.2. And in our formula, we have 3 OHs. And so the reason why I add this is for what we mentioned earlier on in the video. We talked about this. Now, me personally, I always tend to forget to, if I had something like this, I would forget to multiply those things together to get that 4. And so knowing myself, that is why I list out the number of H's and O's, because essentially it's the same thing what we were doing before. So again, before, what we did was, 2 times that 2 in there to get that 4. But in this example, I have our concentration, I have our things. So we're doing the same thing, we're just writing it out in more detail, just so, I don't forget it. And if I'm likely to forget it, you probably are too. So if we do this, we have our formula, MAVA, MBVB. So we have 3 times our VA times 2 equals 1.2 times 50 times 3. And so 3 times VA times 2 is 6. 1.2 times 50 times 3 is 180. So 6 VA. In order to get the volume of acid by itself, divide both sides by 6. Our volume of our acid is going to be 30. And our unit, if our base is in milliliters, our acid is going to be in milliliters, and that is it. So with these questions, it's super important that you list everything out. And the more you list out, the more work you show, the less likely you are to make a silly mistake. But that is it. This is also it for acids and bases. Next time you hear from me will be Unit 11, which is redox. Until then.